Alright, we're going to finish off by looking at some other measurement devices that might be used. A lot of reading these measurement devices, there's just so many different types that you see out there that you might have to just kind of wing it and realize what's going on. So if you're measuring amps, if you have a multimeter or something like that, you might have to just count these out, and you can see we have a 0.2 here, we have a 0.3 here, and there's 1, 2, 3, 4 gaps, four divider lines between them, which means there's 5 gaps. So that means we're talking each of these spacings must be a fifth of the distance between them. So we would go 0.22, 0.24, 0.26, 0.28. That's where those would be located. The one that is currently pointing at is 0.28, because the next one would be 0.30, and that's what that is. So reading this, measurement A would be 0.28. Measurement B, it looks like it's, I'll call that directly between those marks there. So 0.42, 44, 46, I'll call it 0.47. Because 46 would be there, 48 would be there. I'll just call it directly between those two, so I'll call it 0.47. Alright, similarly, something like PSI, if you're reading this particular scale, this is 0, this is 50, we have 1, 2, 3, 4 things, so this would be 10, 20, 30, 40, and, like I said, it's just a matter of kind of reading, seeing what's on here, and being able to read it off. This one right here, we're going in steps of 10, so this would be an 80. This would be a 210. This would be, looks like 5 less than 350, so 345 probably. And this one right here, I'd call 460. Pretty straightforward there. Same thing goes with volts. I would call each of these 0.1 volts because of the spacing, 0.1, 0.2, 0.3, 0.4, 0.5. And you could read those off. I'm not going to bother. There are some scales, especially if you have a multimeter, you'll see this sort of a thing when you're measuring resistance. And this is a variable scale. Down here, where you can see the scale down here does not match the scale up here, because the distance from here to here is a 2, the distance from here to here is 5, the distance from here to here is 10. So you kind of have to figure out where you're at on the scale at various places. You can see this goes all the way up to 1,000, 2,000. It goes all the way up to infinity, technically, if you have discontinuity. So you kind of have to, read these and figure it out as you're going. If this is 10 and that's 15, then this would be 11, 12, 13, 14, 15. So this would be a measurement of 13 ohms. Versus looking at this one, well, okay, things are starting to stack onto each other because they're trying to fit the numbers in here. But it looks like this is 100. These are probably spacings of 10 to get up to 150. And then it jumps up to 200 here. And then, well, who knows what these are. This is probably 300 and then 400. That's at least what I would guess. So where this blue mark is at, I would probably call 300 ohms. Alright, here's a fairly typical example of a non-digital water meter. So with a non-digital water meter, typically what they do is they have a gear in the middle here, and well, actually, maybe it's not a gear in the middle, but it's several gears. It's gear driven, and so what you'll notice is that as your number of cubic feet are increasing, so this is 1 cubic foot here, this will be 10, this will be 100, this will be 1,000, and so on. These are each of your place values. You'll notice that these numbers, they increase going in this direction for this first one. So if I was to read these off, I have this is at a 9 on this one. In the ones place, let me write this down here. In the ones place, I have a 9. In the tens place, you'll notice that now this one is going actually counterclockwise. We started out going clockwise, then this one goes counterclockwise. And so we were between the 4 and the 5. So you might look at this without thinking and say it's a 5, but actually it's a 4 because we're not yet to the 5. So in the tens place, we have a 4. This one is again going clockwise. We're past the 7, not yet to the 8. So we'll go a 7 there. For the 1,000, we're past the 1. So this is again going counterclockwise. You can see the numbers are increasing as we go that direction. We're past the 0. We're not yet to the 1. So that would be a 0 there. Again, we're going clockwise. We're switching directions each time, because really what's going on here is we have a small gear. We have a small gear here, then we have a gear with 10 times as many teeth on it there. Actually, let me figure out if I can draw this a little more accurately. We have a gear that has 10 times as many teeth on it here as a gear there. And so when this one spins clockwise, it causes this one to spin counterclockwise. And then attached to this big gear, we have another small gear, and another big gear here that causes this one to rotate the other direction. So this is what we get when it's a non-digital meter, because it's it's gear driven. All right, so this one, we're at the 10,000th place, so I'll read this one. We're past the 1, we're not yet to the 2 though, so I'll go ahead and put a 1 there. And once again, we're going counterclockwise. We're past the 6, but not yet to the 7. Or, wow. Past the 5, but not yet to the 6. So we're at a 5 there. So if we were reading this meter, we would have 549 cubic feet is what our measurement would be there. Sometimes with non-digital watt meters, you see the same sort of thing. And again, this is because it's gear driven. So the ones place, this one, it looks like it's clockwise. So we get a 3 there. This one is measured counterclockwise. We're past the 5, but not yet to the 6, so we'd have a 5 there. This one is clockwise. We're past the 8, but not yet to the 9. We have an 8 there. This one is counterclockwise. We're past the 4, but not yet to the 5, so we're at the 4. So this would measure 4,853 watt hours. Or kilowatt hours, I guess. If you're using a dial gauge, then a dial gauge can actually rotate in both directions. So a dial gauge is something, if you're trying to measure, I don't know, most commonly I've seen people using them if they're trying to set up something like their table saw blade, and they're trying to get it nice and vertical. I often see people using dial gauges trying to get it exactly at 0 or something along those lines. In any case, how the dial gauge works is this dial will spin around, and each time it spins a full rotation, this smaller gauge, the smaller one down here, will go to 1. So if it goes 1 full rotation counterclockwise, because this blue arrow here, this blue arrow is being used to indicate the direction of spin. So if that blue arrow, if the dial has gone more than 1 full rotation around, then this would go, well, from 0 to 1. If it's gone 2 rotations around, it would go to the 2. And so you can see it must have gone a little bit more than 2 rotations around. So we're at 2 full rotations. And we're actually a little bit more than that. Well, 2 full rotations, this is going to be a number of millimeters. Each full rotation is a millimeter. And since we're going in this direction, you can see the scale actually it kind of looks kind of weird, because it goes 10, 20, 30, 40, 50, 40, 30, 20, 10, and so on. So the scale, you actually kind of have to realize what's going on here. If you're rotating in this direction, instead of 40, you should read that as a 60. This should be a 70. This should be 80. And this should be a 90 if you're rotating in the counterclockwise direction. We are rotating in the counterclockwise direction, but we're not over in that region, so we would actually read this to be, what is that, a 17? Now, you can see this is negative 2.17 millimeters. Millimeters. The negativity there, I'm not sure where they're getting the negativity from, because when you're measuring something in the real world, I don't know how you get a negative direction. It just doesn't make sense. I think what they're doing here is when it rotates in the counterclockwise direction, it's because the dial gauge has been pulled out, because the dial gauge can be pulled out or pushed in. So I think what's going on is when it's pulled out, it rotates in the counterclockwise direction, and that's why they say that it's negative 2.17, because pulling out is somehow negative. I don't know. If it's going the other direction, so this one's going clockwise, because you can see this arrow right here, it has gone not yet 1 full rotation, so we're between 0 and 1 there. It has not gone 1 full rotation, but this is where, reading this scale You don't want to think it's 35 millimeter or 0.35 millimeters. This would go 50. This is 60. 61, 2, 3, 4, 5. This is 65. So 0.65. We end up with 0.65 millimeters is the reading off of that dial gauge. So there's all sorts of different meters out there. These are the ones that we might see in this class. So they're the ones that I covered.